Okay, we should start this module here. It's Kelvin NTC 10K, and it's hooked up to the test system. It's a CAN USB adapter there, and the termination is important here, of course. So we connect it. Before we mount it, we want to see that it works, of course, and we have some power there, and we see that this is on. And we can start a client window, and in this case we run it on socket CAN, and what we see here is the adapter, and it's sending some turn-offs. It's been programmed already, but if we came to setup where we didn't know what devices were on the bus, we would do a scan first, and the socket CAN interface again, and no need to scan more than 5, so we scan the bus, and we find this Kelvin NTC 10K unit, and if we right click on the found device, we can look what it is, and then it fetch data from the device, and we see that it's an NTC 10K, and we have some other info also here, such as version and when the code of the module was last changed, and things like that. You have the firmware version and the update algorithm, etc. If you want to go to and want to configure this module, then you go up to the configuration window, and in this case it's got a nickname of 1, but the full GUID is this one here, and in the configuration window you see all the configurations of the device. This is more or less a way for a technical person to configure a device. An end user will preferably use a web-based thing, and probably a wizard-based thing. And as you see here, you have the same information here. You have all the information from the device. This is actually things that are fetched from the device. So every VSCP device will have its own info stored. This can be a storage that points to an MDF, which is actually stored on the internet, or it can be stored on the device itself. Depends on how much memory the device has. This is typical for registers, and in this case you can see you can set the unit for the temperature presentations. It can be Kelvin, Celsius, Fahrenheit. It's set to 1 now, and you can enable alarms for a low temperature, and you can enable an alarm for high temperature. You can then turn off, turn on events, and you can invert them, and then it continues alarm events and things like that. So it's a lot of things here. So in this case, you have continuous alarms activated, among other things. It's pretty easy to change something here. If you want to something else in it, you just type it like that and write it into the device, and then the new setting is there. So important here is of course that the device can actually be in a location somewhere else in the world. You can also do an update and update all registers. So, and if we look at temperatures, in this units we have some registers here that holds the temperature, and we can read the actual temperature of the device, and we will see that it changes a little. This is an onboard temperature sensor of the NTC 10K, Kelvin NTC 10K. For configurations, you can save the configuration, and you can load the configuration from files. So if you have several units that should be configured in the same way, you can have the configuration on disk and just load it and write it out to the device. Registers are the lowest end way to look at a device in VSCP. So it's 8-bit entities, and we call it a register abstraction model, and everything is actually exported as 8-bit registers. This works for configurations and other things, but look here at the temperature, for instance. It has a most significant byte and least significant byte, generally forming an integer, really. So it would be much better to look at this as an integer, or as a floating point value, or as a string if we like, or something else. And this is what abstractions is for. Here you see the same thing in the form of an abstraction. An abstraction in VSCP tells how a higher end value is stored in register space. And the same here, we can read the abstraction, and it will read the same locations as we have here in the register space. And the same is true for abstractions also. You can they are fetched from the device, and the MDF, the module description file that holds this. You have another thing here, and that's a decision matrix, and we'll look at that on another module. It's not available on this particular module. And then you have wizards. A unit can have several wizards that help users to set up certain settings, or guide them through it. Okay. In case we didn't have the latest firmware on this unit, we can go to the bootloader, and the bootloader looks like this. And socket CAN interface, then it had nickname 1, and if this was a level 2 device, that is a device that is in the world, this is a device that is on a specific interface. But if it was a level 2 device, it would have a UID here, which is 16-byte ID, which identifies it. But in this case we have a nickname which is 1, and what happens here is that it goes out to the device and look what bootloader algorithm it needs, and in this case it's microchip pick algorithm 1, and we can do this manual also, but that's correct. We can select other algorithms there, but this is the right one, and we want to have the firmware for this device, and we know it's a Kelvin NTC10K, and I have it here, and it's a PIC 18F2580, and the latest firmware is there, and we start to program it into the device. And again, this can of course be done with the device that is located anywhere in the world. That is important. The VSCP bootloader algorithm is the best algorithm for this, of course. And then the device is restarted and checked that it is restarted, and we can scan for it again and see that see if it's there, and as you see it is. If we go to session window again, this, we see the events coming from this unit, and what we should do now is to hook up another unit here. We have this one, which is Beijing module. Oop. And it's hard to do this one-handed for sure. If I can manage. Like that. Probably like that. And now we have two modules connected here. We can daisy chain this if we want. A danger when you connect another module like this is that it has a set nickname already, and that you get two modules that have the same nickname on the bus. So you can press the init button here and start a nickname discovery, and when that LED stops to blink, the nickname discovery is ready. I can show you how it looks. First we can check if we really have this module here, and as you see we found two modules and it's nickname 2. We can get some info, and it's a Beijing I/O controller, but we can look at the nickname procedure here, nickname discovery procedure, and take up a client window. Now we will have all this turn on turn off events, but if I press the init button on this, you will see some things coming up. Nude online comes up a couple of times. You see them here. Actually, on this you can see things in more or less clear text. I think it's some stupid thing with the temperature here. It's a bit cold, but it's probably has to do with some settings. But that's it with the modules. You just hook them in and look what they are and configure them, and then they start to work for you. In this case, the Kelvin module have two sensors that check for temperature in the refrigerator, and the Beijing IO module controls a relay, and that relay controls the compressor of the fridge. And in the case of turn off, it will turn off the compressor, and in the case when the temperature goes, I think, to minus 273 degrees is low enough for a refrigerator, so it's turn off. But if the temperature is rising and goes, in this case, goes over 5 degrees, it will turn on the compressor again, but hopefully it will go just to 3 degrees or something like that instead of this. But as I said, this is wrong. Okay, thanks.